Hi everyone, so I'm Meg. For those that aren't totally aware, I will just do a little bit of a background on the Port of Dover. So we're mainly known for the Dover-Calais ferry route. It's 33% of all UK-EU trade, so it's a really, really big portion of the trade the UK does. That's partly because we have 52 crossings a day. So, you know, very, very, lots and lots of traffic comes through us. But with that traffic and all of that trade does come a lot of emissions. So if you look at the system as a whole, so that's the ports on both sides and all those vessels, it's 1.1 million tonnes of carbon a year, which is equivalent to 8% of UK maritime domestic emissions. So yes, we're a really big part of trade, but we're also a really big part of emissions that we need to do something about really desperately. So the port's been working on doing lots of things for our own emissions for a number of years. We started reporting our own carbon footprint back in 2007. So we've got quite a baseline from a little while ago, and we had kind of like a generic target of reduce it by 5% every year from 2007. But then in 2022, we decided to kind of formalise the target a bit more and put out a proper sustainability strategy with our own net zero target. So for Scope 1 and 2, it's 2025, and Scope 1, 2 and 3, it's 2030. For our Scope 1 and 2, we've managed to do 96% reduction so far since 2007. We've just got 4% to go. So I'll talk a little bit about all the things we did to get that 96% reduction, but then the kind of more important part is what do we do about the actual system as a whole, because it's brilliant that we've reduced by 96%, but of that 1.1 million tonnes, we're a teeny portion. So we really need to work as a system to have the proper impact that we really all want to have. Some of the things we've done at the port, back in 2016, we decided to move to REGO electricity, which is the Renewable Energy Guarantees of Origin, I think. We also installed 1.5 megawatts of solar on the port buildings back in 2019. We'd really like to install more solar, but we have lots of issues with around space. Not every port has this problem, but we definitely do in Dover. We've got the White Cliffs on one side and the sea on the other. We don't have any room to expand, so we've got the space that we've got. And the majority of our space has really got to be dedicated to getting traffic through the port as quickly as possible so that we don't have the blockages that I'm sure everybody's seen on the news at some point. So therefore, for space for renewables on site is really difficult for us. So we have been able to put solar on some of our rooftops. A lot of our rooftops are kind of listed buildings, quite special buildings, so are not allowed to have solar on for that reason. So where we've been able to put solar has been on new buildings that we've purpose-built for that. We also transitioned all of our landside plant and machinery and then vessels as well. So that's the port-owned vessels. So that's our pilot vessels, our tugs, our dredger, our survey vessel to HVO. We kind of see that as something we could do immediately. None of our vessels or cranes, for example, needed replacing right now, and we didn't want to kind of go out there and spend lots and lots of money and get rid of something that there was nothing wrong with. So what could we do in the interim before it needs replacing? And that was, for us, is HVO. And then as and when each of those things need replacing, we intend to look for a net zero option. So whether that'll be electric, hydrogen, will depend on the piece of kit. But for us, HVO has been something we could do immediately and has been really successful. As has been mentioned a lot of times, it does come at a much bigger cost. We're also a trust port. I think most of the ports that have spoken have been trust ports. So with that becomes we don't have shareholders, so we can be a bit more broader thinking with kind of the things that we do for the port that also matter to the community as well, because that's really important for us. We've also, as we speak, installing EV charging points across the port. That's been really difficult for us because of energy constraints, believe it or not, even for an electric vehicle charging point, let alone any sort of power for vessels that I'll come into in a minute. But hopefully those will be all finished by October. And then we also transitioned our cargo facility to a brand new building that had lots of solar on top, as well as running on different fuels for some of the kit that works there as well, which has helped to save quite a lot of energy. Now, some of the smaller things that we did that we don't often talk about, but when you look across the whole port estate, they actually do have quite a big impact, is lots of our lighting. You'd be surprised how much energy we use from high masts from all over the port, because we are 24/7, the ferries still go in the middle of the night. We also, when we moved to the new cargo terminal, which you can kind of see there when it was during construction, were able to lower some of the chiller points because we made the building much more efficient and insulated, which allowed us to keep all of the bananas. I think 90% of UK's bananas come through this cargo terminal at the right temperature without having to use as much energy. One thing we found is all the HVAC systems in every single building in the port, all the sensors were in the ceilings because that's how they come installed, but the sensor for what the temperature is right at the ceiling of the room isn't the temperature that you feel as a person in the room, so we can actually save quite a lot of money on heating by just moving the sensors to the same level that people sit at, which is a really small thing but has actually had a really big impact. And then all of our port-owned vessels moved to shore power quite a few years ago. So when they're moving around the harbour, outside the harbour, they're on HVO, but when they're alongside, they are all plugged in. So now the slightly bigger piece is the actual system as a whole. So that's the Green Corridor work that we've done. So I thought before I get onto our Green Corridor project, I'd just do a little background on how we got to looking at becoming a Green Corridor. So we did a CMDC1 project looking at hybrid vessels. I don't know if anyone knows, but we've got 2 very large double-ended hybrid ferries on the route right now that unfortunately can't plug in at either end at the minute. So they just burn their engines while they're crossing the channel to charge the battery so that they can then enter and exit ports on battery. So it's good for local air quality, but emission-wise is the same as a standard vessel. And so this project was really to look at what's the actual duty cycle of these ferries going to look like. The ferry operator purchased those vessels really without discussing with the ports what it was going to look like. We didn't really know what power they would need, how that would work in the port. Vessels arrived one day. So we really needed to understand what can the ports do and how can we support this. And some of the guys at Warwick worked on this piece of work here for us, and they looked at what's the duty cycle going to look like. The blue line at the very bottom is our existing port demand. I think we use about 2 megawatts in our ferry terminal to kind of power buildings, and we have 4 megawatts as what is available to us from the grid. And that green line is very far away from the blue line. That green line is if we had 12 hybrid vessels, because that's how many vessels we have on the route in total. And when our CEO saw that, he was very shocked. I think we all knew we were going to have a deficit. We weren't aware it would be this huge, and this is only hybrid vessels. We kind of knew from the ferry operators that their end goal ambition was to be fully electric. So this was based off the hybrids that are on the route now, and they have around roughly enough batteries to get 50% of the way. So we kind of went, it's going to be double that effectively, isn't it? It's like a rough calculation of what it's going to look like fully electric. So that kind of scared a lot of people at the port in a good way, that made everyone kind of wake up to we really need to look into this and do something about it. So when the CMDC call came up for Green Corridors, we thought, brilliant, it's perfect time for us, we really need to look into this. So there's a little picture of our group, but we worked with the University of Kent, Warwick University, and all of our ferry operators. So for those that don't know, it's DFDS, Irish Ferries, and P&O. P&O already have the 2 hybrids on the route already, so they're here right now. But DFDS made a lot of commitments. I don't know if anyone saw it in the news reasonably recently that they're going to go fully electric. So they told us this in advance of the bid, so we knew that they were very, very keen on fully electric. But again, we really need to understand from them the details of what does that look like, because they have 5 ferries, very large ferries, 52 times a day. That's a lot of electricity. So I'll just run through what we did in the project here. This is a kind of a list of everyone that we talked to at the beginning, because we knew that the ferry operators were thinking electric. We knew that, but we thought, we still need to speak to all of the hauliers. What's that going to look like? Is it going to be hydrogen? Is it going to be electric? But also cruise and cargo. We're often only thought of as like a ferry port, but we are the second busiest cruise port in the UK as well. So we do have a lot of cruise ships, and then our cargo business has got a lot busier in the last few years as well. And so realistically, a cruise ship isn't going to become fully electric, but we still, if we can help understand what they need from a shore power perspective, we can kind of lump all that together and look at that as a whole. So this here is a graph from the guys at Warwick that looked at all the different fuels that the ferries could run on. So this is based off of the actual ferries, the duty cycle, what it looks like, which is 364 days of the year. And then the last 3 lines, you might not be able to see it all, is electric, but based on the grids in different countries. So I think the 3 in is UK, then it's France's grid, and then it's Norway's grid, just to kind of demonstrate that if you decarbonise the grid, you could bring that down even further. But yeah, a nice little fact there is that Dover Harbour board vessels, so that's a dredger, tug, survey vessels, pilots, emit in a year what 2 ferries emit in a day. So when I said we're a very small portion of it, we are. So we kind of knew that the ferry operators wanted to go electric anyway. They'd made their mind up and they told the ports what they were doing, but we still at least were able to demonstrate that probably is the best from an emissions point of view for the corridor. this graph here shows you, for fully electric now, not just hybrid, the kind of duty cycle of what that might look like. We've got it into 4 scenarios because we're very aware that we're not going to wake up tomorrow and there's going to be 13 electric ferries. It's going to happen in a staged process. Some of our operators are much more ambitious than others. 2 of them, one already has gone to hybrid, and another one intends to go hybrid first, whereas DFDS intends to go 5 fully electric immediately by 2029 and 2030. So this kind of shows you what that looks like from a duty cycle point of view. It's very, very often that we'll have 2, sometimes even 3 ferries in at the same time. They're only here for 45 minutes, so that's not a very long amount of time to charge. The kind of amounts that we're looking at here, the P&O vessels is about 30 megawatts. The DFDS ones we're hoping will be a little bit lower than that, which will be a bit more feasible, but it's a lot of power in 45 minutes. So you can see here the black line is the ferry load and the pink line is what the grid told us they could supply at those kind of points in time, best case scenario. So we had a feeling that they wouldn't be able to supply everything we would need. So we kind of needed to understand how much are we going to have to meet from either a different source or through some sort of storage, whatever that might be. But also, I think something to point out here is everyone can see how peaky that is. When you have a ferry come in, that's a huge, huge amount of power, then it's immediately going down when they leave. So our ferry schedule is all about efficiency from a logistics point of view, get in, get out as quickly as possible. We have 10,000 trucks a day, we need to get everybody moving. We've never looked at it and gone, well, if you stayed 5 minutes more or you waited 5 minutes before you came in, how much can we bring those peaks down from an energy perspective, which is something our operations teams don't love to talk about, but it's something that we're going to have to consider because there's got to be a way to meet that pink line. So some of the optimization opportunities, you can see the difference between the pink line and the black line. What might that be? So a private wire from some sort of renewable energy is kind of an obvious choice. In Kent, solar is really ramping up just because of the sun. But we can't do any more at the port. How far away from the port are these solar farms that are popping up going to be? Looking at it from a commercial point of view, they're probably a bit too far away to make it feasible to get that power to the port. We're not sure how feasible that is going to be now. I already mentioned the ferry schedule optimization and then also some sort of battery or energy storage situation and integration. We, again, have not very much space at the port, so we're always talking about all of these batteries we're going to need, but where are they going to go? We've got very, very limited space. We have some caves in the White Cliffs of Dover that were used in the war that are empty, that lots of people have some ideas that we could fill with batteries, but from a safety point of view, is that really a great place to fill with batteries? Not so sure. So we've had every idea under the sun of where we could put all of this infrastructure that we're going to need. And something that isn't on this slide, because it kind of gets forgotten when we talk about the sheer amount of power we're going to need compared to what we have, is that we have 3 ports and we have 3 ferry operators, and none of them work on the same voltage. Nobody wants the same frequency. Nobody wants to plug in the same place. And we can't have 3 plugs on every berth in every port because that's too expensive. So the actual physical connection point of transferring that power is something that we have some interesting debates about all the time between the ports and the ferry operators. What's that going to look like? We need to pick a voltage and a frequency. We can't have a mix because it's just too much money to have multiple plugs on multiple berths. So getting the competitors to work together and share that kind of information has been a challenge for us. It's brought Dover and Calais as ports much closer together, which has been really great from us. Initially, their response to this was, well, that's a vessel problem. They want a new vessel, they want electric, they can sort it out, we're just a port. And then when they started to see that as the port you can play a part in what the solution might look like if you get more involved in the project, that's been really great. They have woken up to that and are really engaged with us now, which has been brilliant. Sorry. So some further government mechanisms. The main issue for us is the price of electricity. It's much, much cheaper in France than it is in the UK. Currently, the ferry operators, with the batteries that they've picked in the vessels that they're planning, or the ones that are already here, they can't do a round trip. They'd have to plug in at both ends. They have no choice. But there will come a day where they won't have to do that. And is either port willing to spend hundreds of millions of pounds to install infrastructure when, 10, 15 years, they only have to plug in at one side? They're going to pick the side that has the cheapest electricity. That's not going to be us. So that's something that we really need to think about. We need to figure out a way to level the playing field, but also the price of electricity just doesn't compete with marine diesel. So how do we work that one out? We'll quickly flick onto the last slide. This kind of shows you the timeline of what the vessels want to do on what years, the power that includes, and some costings. As a caveat, This was based on estimates from the grid. We've since had much more accurate information from the grid, so the costings have shot up quite a lot, which when it's already 92 million isn't really a great thing to hear from the port, but you can kind of see here the scale at which we're looking at with a peak demand of 162 megawatts when we have 4 megawatts. It's a huge, huge deficit that we have in Dover. I mean, Dover District Council, just for context, can't even install any more car chargers in the town because there's no power in Dover. So it's a really fun challenge that we're attempting to solve at the minute. Almost all of our engineers' time is going into this exact problem of how do we get the power, how do we transfer the power into these vessels? So there's lots of work. I could ramble on about it for much longer, but we'll stop there. But happy to answer any questions if anyone's got anything they want to.